Hi, during last week and this week I have been working in very interesting task. So we have existing pipeline and we want to move away from the existing pipeline. Let me explain first what we have and then uh, what are we migrating to. Right now we have several small microservices. We are using Nest.js. It's a very interesting framework to build back-end applications. You can check it online. I really like it. And we have GitHub to push our source code and as our main source code repo. And then we have a setup for CI/CD on AWS. We are using code pipeline to run our build, make sure the code is not broken, and to deploy the code. We are deploying on Elastic Bean. Again, it's AWS service. It is just kind of a pre-configured EC2 machines. Just you remove the heavy lifting from your side to AWS, the configurations, the setups, and so on. You just have some clicks and then it's deployed. Just configurable EC2 machines. So why do we moving away from this setup? The reason is because Elastic Bean is not stable. It's not stable. We have some issues. How do we see those issues? When we are deploying, building a lot of times, sometimes the machine just broke, they are not working. We just face random issues on Elastic Bean. That's the main reason why we're moving away from Elastic Bean. For code build, it's the same issue. We have sometimes the build have some problems. It's just broken or something. And we are really suffering because of this issue. You have suddenly in production, the build is the machine is just stopped or have some problems and you don't figure it out. People just report issues and then you check everything is fine, but you find out that the machine in some point it just have some problems randomly. And also for the build, you build and then it just fail. You check, there is no problem from your side, but the build have an issue. You have to rebuild again. So we are facing some random problems, some random issues, which we don't like. Plus, to build the pipeline itself, like if we have a new application or we want to build a new application, it's a problem to, not a problem, but it's a bit of effort to build the pipeline. It's a bit of effort. It's not that simple process. And also on the cost matter, it costs a lot of money. The machines cost a lot of money and they are reserved machines. They are not elastic. Again, you have capability to increase the capacity for machine, decrease the capacity for machine, scaling, and so on, and you have automatic scaling. But again, the cost is a bit high. I think those are the main reasons why we're moving away from Elastic Bean and the pipelines. Also, it's slow. The pipelines is a bit slow. You have to increase the machines, and again, it's costly if you would like to have a better performance. So this is what we have, and this is why we don't like it very much. And you will not feel the difference until I talk about the options, the other way around, the other side of the story. So what are we moving for? Basically, we are moving to Kubernetes. So Kubernetes give you much better control over your resources. What we are doing now is to migrate to Google Kubernetes. We have migrated some of the services. We are working migrating the others, but we are moving to Kubernetes in Google Cloud. I see it's much better. We have more control over our machines. The cost is a bit lower. It's not that much lower, but it's lower. Right now, even Google gives an option to pay per pod. So every pod You deploy, you pay for the pod. So if you have 2 pods, you will pay only for 2 pods. If you increase, it will be if you scale, you will pay for the pods which are online, which they are active. So it's very interesting way to pay your bill. I like it, and we expect it will reduce our cost significantly. Add-on, the configuration is not that difficult to configure Kubernetes. It's not that difficult. If you know Kubernetes, it will not be hard. So what are the new setup? So the new setup is as following. The same backend, we have the same backend, but we added 2 things. First, we added a Docker file to build the Docker image. And then we added another piece is Helm charts, so that we can deploy the image on Kubernetes. We use Helm so that we can make the process for deploying new updates. It's much easier using Helm, and integrated on the CI/CD is much easier to use Helm. Without Helm, it's a bit tricky. So Helm is making our life much easier. Plus, the same Helm chart, you can use it in several projects. Basically, we have the same Helm chart in all the projects. So you don't have to keep creating again and again the files. You just have to add the differences, the parameters, the different parameters between projects in a values, the values file, the famous values file, and the chart file, and you are good. You don't have to do a lot of setups. Once you do it one, and then you just apply. We actually have 2 charts, one for the APIs, REST APIs, and another one for background processing, batch processing. So we don't have a lot of complications. If you would like to create only Kubernetes files, you will have to create for each project its own Kubernetes file. And again, to roll up the updates, it is not the best thing. So we use Helm, and we add the Docker images explain, and we move the pipeline to GitHub Actions. I really like GitHub Actions. It's very interesting. It's fast, and it's customizable. The customization is very simple to customize it, and to run the code, and build it, and make sure it's not broken, and push it. In our case, we push the Docker images to container registry in Google Container Registry, so that we have all the Docker images before we pulling them on Kubernetes. Of course, if you know Kubernetes, you know what I'm talking about. But in summary, you need to build a Docker image, you push it on a repository, and then in Kubernetes, you pull the image and start a machine. We call it, you should start a pod, small pod. It's a computing unit somehow. So we use GitHub Actions, very interesting, and it's very fast. What we do is we build, we have, of course, the pipeline is on the master branch to push to development environment. And for other environments, we use tags, we use manual deployment for production, for example. So different environment, different setups. But basically, in the development, when the code runs with HBR, we make sure that the code is building and so on. And then when we merge, we push a new image. When you push a new image to the container, plus we roll out a new version in Kubernetes. So once the PR merged with master, we run Kubernetes, we run a Helm update. There is a Helm upgrade, sorry. And then we change the image to update to the new image. So this is the full pipeline. It's much simpler. If you compare it with what we have in the past, this is much simpler to kick off a new project, especially if you are working with microservices. You need to be easy to push a new project, change existing project. It's very important. In Kubernetes side, we don't have a lot of configuration. We are using Kubernetes autopilot. Autopilot, it start a machine. We just have initial setup. This is what we spend some time, some effort to set up ingress, to set up the network, how the network inside Kubernetes will be. We have 3 clusters: development cluster, we have a production cluster, we have a staging cluster, and each cluster inside we have a namespace for each application. So each application have its own namespace, and it has inside the namespace you have all the components you need for this application. It's just a separate unit by itself, and we have it should be a shared network between the cluster. I think this is all about our setups. We are using Route 53 in our case to manage the traffic inside the cluster. So the request come to Route 53. Route 53 redirected to the cluster with the IB. Then inside the cluster we have ingress, which routed to different names, different services. We don't have shared. In our case, we don't need shared IB. We don't need it. Maybe in your case you will need, but in our case we don't need a shared IB. We just each service has its own IB. It has its own network, and it has its own namespace. They are isolated from the other services, and if you would like, you can call every service with its external IB, then you get in. So if you send a request to external ID, it will be routed. Ingress will route it inside to the endpoint you would like to route to. We also have certificates management. We have TLS, HTTPS, TLS certificates, HTTPS for security. So Google make it very easy to manage the certificates. You just have to put some configurations and make sure that you have a static IB, and then Google will take care of the rest. You don't have to do a lot of effort. And this is one of the things I like about Google. Google Kubernetes. It has the least configuration, best cost, and best setups. I think Google win the game when it comes to Kubernetes. There is a bunch of details, but I think this is the outline. How do we set up? This is a very quick overview, and why we migrate. It's much better, much stable now, much far better than Elastic Bean, and you have a lot of control over the boards, the machine, and so on. Deployment is much faster. It's much better than what we have in the past. I hope this makes sense to you. You can share with me your experience as well if you have different one. I'll see you in the next video.